So in this video, we will look at gas expansion and what happens in terms of work. So anytime a gas expands or contracts, it does work against the surroundings, or the surroundings does work to the system. So here we have a gas expansion. It's moving from initially 26.7 milliliters to a final volume of 89.3 milliliters. So obviously the gas is expanding, shown here. When it expands against the surroundings. So it's doing work. We would expect the work done by the gas to be negative because it's expanding. Now, if the surroundings were compressing the gas, we would expect the work done by the gas to be positive and the surroundings to be negative, an equal value but opposite sign. So anytime a gas expands or compresses, there is pressure. There's a change in the pressure. And also there's work done. So the equation here is the work done by a gas is going to be negative the pressure, because that's what happens when a gas expands or contracts. There's a change in pressure. Negative pressure times the change in volume. So let's go ahead and solve this for against a vacuum. So against a vacuum, it's going to be 0 joules. Okay, so against a vacuum, there's no interaction between surroundings and systems. The systems is not in contact with the surroundings. The surroundings is not in contact with the system. But part B, so you'll do 0 joules of work in a vacuum because there's no interaction between the system and surroundings. What happens if this gas expands against an external pressure of the surroundings of 1.5 atmospheres? So here we have minus 1.5 atmospheres. Our final temperature, our final volume is 0.0893 liters. Let's convert everything to liters here. Okay, that's our final volume, converting it to liters. Our initial volume is 26.7 milliliters. Let's convert that to liters, the SI base unit for volume. So that's going to be 0.0267 liters. All right, 0.0893 minus 0.0267. On my calculator, I'm getting 0.0626 liters. And that times minus 1.5 atmospheres gives me minus 0.362 joules. Okay, excuse me, minus 0.00358 liters atmosphere. Okay. So the problem, if you remember, the problem asks us to solve this, solve the problem in units of joules. So our units are atmospheres. So the conversion from liters atmospheres to joules is that 1 liter atmosphere. And again, I got this from the textbook, so I had no idea. But to convert it to liters atmospheres to joules, 1 liter atmosphere is 101.3 joules. And you can see here the liters atmosphere cancel, and now you're left with minus 0.362 joules. Okay? So minus 0.362 joules of energy are required. The negative means that the gas is expanding. It's working against the surroundings. So that's against the pressure of 1.5 atmospheres. In part C, you're doing it against a pressure of even more, 2.8 atmospheres. So we would expect the gas to do more work because it's now, instead of 1.5 atmospheres, it's pushing against 2.8 atmospheres provided externally by the surroundings. The final volume was 0.0893. The initial volume is 0.0267. Okay, these are all in liters. Doing this math on my calculator, I'm getting minus 0.175 liters atmosphere. And again, the conversion to joules, 1 liter atmosphere is 101.3 joules. Again, I got this from the book. And you should expect to do more work, and you do minus 17.6 joules of work.